Um, so welcome everyone to my talk about repo jacking and how GitHub usernames expose 70,000 open source projects to remote code injection. I'm Indiana Moreau. I work for Secure Innovation, and today I'll be talking about repo jacking, which is essentially a novel supply chain dependency vulnerability that's extremely widespread in open source projects. So we'll kind of explore how that works, how to exploit it, how widespread it is, and then we'll also talk about some remediation strategies and also kind of supply chain attacks in general. So when I start talking about supply chain attacks, I'm not talking about hardware supply chain attacks, which is like a whole different beast. I'm talking about software supply chain attacks. And I can't really talk about that without talking about SolarWinds. Obviously, everyone's heard of SolarWinds in the past few months. A huge hack, and that was a software supply chain attack. There's been a lot of other notable ones like Mimecast, ASUS, CCleaner in the past couple of years. And it's kind of it's a whole attack field which is kind of on the rise. Specifically, with SolarWinds, it's a type of supply chain attack where you're hacking this company, and this company is used by a bunch of other companies. But I want to talk about a slightly different type of supply chain attack, which is dependency supply chain attack, and more specifically, open source supply chain attacks. So everyone uses open source, right? Everyone knows open source. According to the Sonatype 2020 State of the Software Supply Chain report, 90% of modern application is just open source, which makes sense, right? Because you use a web framework, you use a pre-made SSL library or whatever. So this is obviously a very important aspect of your application to secure. Cyber attacks in this range are growing, apparently up to 430% year-to-year growth. Because targeting this open source library, if you can get this one library, you can hack, and break into a lot of other things. So it's extremely important to kind of secure these because they're a huge part of an application. And when you're talking about open source, a lot of open source is stored on GitHub, right? GitHub is a website that hosts most of the world's open source. And basically everything, anytime you're looking at open source application, it's most likely going to be stored in GitHub. So if it's important to secure open source, it's even more important to secure GitHub because GitHub hosts all these, right? So all these libraries that everyone is using, GitHub is the source of truth for those. So if you could find a vulnerability in GitHub, you could potentially exploit it to exploit some other dependency down the line. And so when we're talking about open source kind of supply chain attacks and vulnerabilities, they're slightly different from attacks like SolarWinds attack. Because in SolarWinds, like the attackers went after kind of the biggest target, right? SolarWinds, because SolarWinds is big and a lot of people depend on it and such. But with open source and dependency supply chain attacks, the valuable targets might not be so big. So this is a website, libraries.io, and they maintain a page called Unseen Infrastructure. And the premise is basically they make a list of libraries that are immensely popular or immensely depended upon, but there aren't many contributors. So like if we look at the list down here, we've got like ConCatMap, for example. It's got 800,000 dependent repositories, but it's only got like 30 stars on GitHub and one contributor. So essentially this one contributor, this one application is used by a whole bunch of others. And these are all kind of different popular ones that use this. I'm sure you recognize a lot of these, right? So all of these are loading in code from this one contributor. So it's kind of a really valuable target. If we actually look over here, like Angular, for example, the third one down, AngularJS is actually what's used in the front end for SolarWinds. So if someone wanted to, break into SolarWinds again, all they'd have to do would be to, break into this one app, this ConCatMap. It'll get loaded in by Angular. Angular get loaded in by SolarWinds, and then you're in. But maybe you don't want to break into it. Maybe it's too hard. You want to go the easy route, and maybe you just ask the developer if you could have it. And this has actually happened in the past. Back in 2018, there's a very popular library called EventStream. Same type of deal, right? Loaded in by lots of things, and it was maintained by one guy, and he was onto other projects, right? He just had that kind of sitting in the background. So someone came up to him and asked, "Hey, can I have this library? Like, can I maintain it?" And he said, "Sure." Passed it over. And soon after, the person was actually a malicious attacker, and they loaded in malware to that library, specifically targeting crypto wallet. They were actually caught, but not the person, unfortunately, but they were caught in their attempt, but only because they used a deprecated API in the malicious code. If they hadn't used that deprecated API, there'd be no warnings that would come up, and to this day they might not be caught. So that's kind of an example of one of those really core libraries being taken over. But let's say you don't want to find like a vulnerability in one, and you don't want to ask the developer because you don't want to talk to people. Cue repo jacking. So that's where repo jacking comes in. I'm going to kind of get a little story about how I actually ran into repo jacking. So it started with, I had an engagement working for a big client and doing a standard source code review, so looking through the dependencies and such. And I run into a GitHub URL. So they're linking directly to a GitHub URL and loading code from that. So I search it up. I follow the user, so whatever user it's pointing to. And when I try to browse to that user, I get a 404 error, user not found, from GitHub. So it's kind of interesting because they're clearly loading code from somewhere. So then I browse to the full repository, and it directs me to a repository, but for a different user. So I was getting redirected to a different user's repository. And that was really weird because I thought, hey, this GitHub link is pointing towards this user. So what I did is I went onto GitHub, registered a new user with the same username, and it worked. And then I created a new repository with the same name. And now this code that I was auditing essentially was loading code from this newly created user. And that's the premise of repo jacking. So what happens is GitHub allows username reuse. So when someone renames or deletes a user, their username on GitHub, it's going to allow anyone to re-register it, and any kind of previous URLs pointing to that are going to be affected. Because if you look at like a GitHub URL, you've got the GitHub domain, right? That's pretty static. That's not going to change. Then you've got the repository all the way at the end. That's kind of dependent on the user, right? The user gets to name that repository, but then you have the username. And if this username can be reused and taken by anyone, essentially whenever someone deletes their account, renames their account, that username is going to be available to be re-registered. And so anyone could re-register that username and then recreate a repository, and then that they've got full control over what's being loaded into code. So a couple of points about repo jacking. It's conceptually similar to S3 bucket sniping or subdomain takeover, if you're familiar with those, where essentially, you're pointing to a location online, an online resource, but that resource is available for anyone to claim or anyone to register. It often results in code injection just because GitHub stores code. So people are often loading code off of GitHub and running that as a dependency. So it often results in code injection, which is pretty bad. And the other kind of scary part is that you can become vulnerable without changing your code, right? Because you might have a dependency that is pointing towards a GitHub URL, right? Like in this case, let's say Twitter/Bootstrap or whatever. If Twitter were to delete their account, anyone can now reclaim that or make a new account with that Twitter name, and then you haven't changed anything in your code, but you're now vulnerable to repo jacking. And obviously, since GitHub is public, anyone can exploit it, and it's pretty trivial to do so. So there's three main scenarios when talking about repo jacking that can make an account essentially, or a repository or URL vulnerable to repo jacking. Scenario number one, a user deletes their account. That's the obvious one, right? Someone deletes their account, so obviously it's up for grabs from anyone. And any URL pointing to that are going to get hijacked essentially. And this actually happened in the wild before. So Kodi is a video streaming platform, and it has add-ons, and a lot of those add-ons load code in directly from GitHub. There's a popular add-on that would load code from GitHub, but then that user deleted their account. So now that's available for anyone. And someone else did actually create a new account with that same username and now had control, and they pushed updates and stuff. It wasn't malicious, but it could have been. So that's scenario number one. So the thing with scenario number one though is that most likely when a user deletes their account, all the repositories are gone, right? So anything that was linking to that URL is going to break. You're going to get a bunch of 404 errors, and obviously people are going to investigate that and look into it and say, like, oh, this user doesn't exist anymore, and they're going to change the location of that dependency. So that's kind of a big flag that when that goes on, and you'd have to be like a well-timed attacker to be able to monitor all the usernames when one gets deleted, re-register it, and take over that way. Scenario two, though, is a little more complex. The user renames their account. So it sounds the same, right? Because in GitHub, you can rename your account. That's good. But then your old account name is now available for registering from anyone. But there's a little something called repository redirects, which I'll talk about in a second here, which makes this a lot more dangerous than scenario one. And then scenario three is a little more niche for sure, where a user transfers a repository over and then they delete their account. And this also sets up a repository redirect, which I'll kind of talk about. So repository redirects. This is a feature of GitHub that was introduced in 2013, and they got a little blog post about it. And essentially what it is that whenever you rename a repository or you rename a user, GitHub is going to set up some really handy redirects. So any of your old URLs are going to point to your newer URLs. This is really good for like developers because it doesn't break all of your code. So if you're pointing towards it from somewhere else, it'll just redirect you seamlessly. So that's really nice. Unfortunately, it can also be really dangerous because it means that now when someone changes their username, that username is up for grabs. So anyone can do it. So they're vulnerable to repo jacking, but no one knows because everything works the same. Any old link works the same, and that's what happened in the case of that first repo jacking. Basically, it was redirecting somewhere else, and even though it was vulnerable, no one knew because it was getting redirected. So here's an example of this repository redirect at work. This is the GitHub. If you go to github.com/Twitter/bootstrap, and you can do this right now, it'll redirect you to somewhere different. It'll redirect you to github.com/TWBS/bootstrap. And this is because Twitter probably create a new account specifically for Bootstrap and transfer the repository over. But the old link will still work. Now, when that repository redirect is created, it'll continue working indefinitely unless a user is recreated with the same username in the same repository, right? And that's how you would hijack it. So in this case, obviously they won't do it, but imagine that Twitter were to delete their account. Anyone could then re-register that Twitter name, and they would be able to recreate that Bootstrap repository, and any of the old redirects that would redirect to TWBS, which is the legitimate repository, would now go to this new repository and code would be loaded from it. So that's essentially repo jacking in a nutshell. Once we found this, obviously we fixed it pretty quickly. But then we went to GitHub and we said, hey, GitHub, this is a problem because all these people who are linking to your URLs don't realize that this is bad. And as a quick note here, this also works for Git operations. So like a Git clone or a Git push will get redirected. But yeah, so we went to GitHub and we told them this is bad, right? And they said, yes, we know about this. And they kind of pointed us to a link. And so this is something they've done a while ago, which they basically retire the namespace, which means that they don't allow their repository to be recreated for any project that had more than 100 clones in the week leading up to the owner's account being renamed or deleted. So this is kind of a mitigation that they implemented to ensure that really big repositories aren't being hijacked. So like they've got examples here, for example, like Microsoft TypeScript or Swagger API. Those are really big repositories. And because of this, if they have 100 clones in the week leading up to their deletion, then no one can re-register it. But we have found, or I found when I was doing kind of a more in-depth research on where these URLs are being used, is that it's not these big repositories which are vulnerable, right? All these big repositories are going to have a package manager package somewhere, right? So anyone who's going to want to access those will just pull them in from a package manager. But the bigger issue are people who are doing like a fork of a common repo and then changing just a bit of code and then relying on that direct GitHub URL of their fork, right? So it's always, if the dependency is big enough, it's going to be in the proper package manager. It's always the small ones that get you. And if we look at like the old example of Concat Map, that's got 30 GitHub stars and 1 contributor, you know what I mean? So if someone were to link directly to that, maybe that hasn't had more than 100 clones in the past week. So we do find, I found that this mitigation can be good for the bigger ones, but definitely doesn't fix this issue everywhere. So once we knew about this repo jacking, GitHub wasn't planning on fixing it, or they had their mitigation already. I decided to kind of take a look on just how prevalent it is, because I've seen that a bunch of times in code. I've probably done it myself quite a few times, linked directly to a GitHub URL. So I want to scan through all open source code that I could and see just how many people are linking to GitHub URLs. How bad is this? So I'm going to walk through the different steps I took. So step 1 in this process was the data collection. So I had a couple of data sources to actually pull the data from. First one here being the GitHub activity data. This is published by GitHub. It's a 3 terabyte data set that includes 3 million open source GitHub repositories and the full source code for each one as well. Really good because I could search through this, find any reference to a GitHub link, and kind of go from there. But the only issue is that it was last updated in 2019. So the data is not super fresh, but it still can yield a lot of good information. And the second one was from the same place I mentioned before, libraries.io. They maintain like an indexed database of dependencies and packages that depend upon each other. So this was a really good source for that type of like reverse dependency analysis. So I kind of used that on the secondary steps over here. So I went through all of that and I came out with a list of about 4 million unique GitHub links in source code. So that's a lot of links. And this is basically anyone or anything that linked to a GitHub URL. But that's not, that's not necessarily all the impactful links. So step 2 is the cleanup. Because you might have a link like the one below in a README file, for example, where it's not going to result in code injection because it's just in a README file, or like a comment of a file, for example. None of these are actually particularly interesting because even if you were to take them over, you wouldn't be able to get any kind of code injection, right? We're more interested in like something like this. This is a Docker file that does a wget on a GitHub URL, and then obviously runs the code there. So for example, if this protocol buffer / protobuf URL was hijackable and vulnerable to repo jacking, then this would result in you being able to get your code running inside this Docker container. So we had to do that cleanup. And the other thing we had to be wary of is that different package managers had the ability to link from GitHub directly, but in different formats, right? They all had slightly different formats, so we had to make sure we were catching all of those. And the one which I found was interesting is like, for example, NPM and Ruby Gem does the same thing, where you have the shorthand format. So instead of putting the full URL, if you just put the username / repository name, NPM is going to know that you mean on GitHub. And that kind of speaks to just how common it is to link to code directly from GitHub, right? Because they even have a shorthand version from it. So you have to make sure to catch all of those. That was the cleanup. And so we got rid of all the uninteresting links. We're left with 2.1 million unique impactful GitHub links. So these are links that are going to load code. And if you can hijack these, then you're in. So after that, we trim it down to just the GitHub usernames. So we've got about 650,000 GitHub usernames you have to scan through. The GitHub API only allows you to do 5,000 requests an hour. So it took a while, but we managed to look through all those usernames and find all the ones that currently don't exist. Because if it doesn't exist, it can be re-registered. And therefore, any link that is part of that username can be hijackable. So we did that scan, and it turns out about 7% of the usernames you found were unregistered. And that's a lot bigger than I thought. I was expecting like sub 1% maybe, but 7% is a huge number, right? Obviously, people get bored of their usernames far more than expected. And this was kind of the point where I realized just how widespread this was going to be. Considering that basically this meant that we had 92,000 GitHub links using source code in a meaningful way that could be hijacked. So the next step is just a simple kind of reverse search for any place or any source code that used one of those links. And it turns out about 18,000 open source projects are directly vulnerable to repo jacking. And that is a lot of projects. And these kind of range from everything from super large organizations like Google or GitHub to like small personal projects and such. So here's an example of one that we found, Algorithm Search Helper. That's the name of the package. Version 3.2.2, since disclosed, it has since been fixed. But basically in their package file, they were linking directly to the Superwolf / Middle and Smith place. And that is a repo, like a GitHub repository. So we found this, so we take a look. First of all, does the original user exist? Search up Superwolf, does not. So obviously the user changed their name or deleted their account. And then you actually check the actual repository Mailsmith in place. And if you go here, it's going to redirect you using that repository redirects to this repository, the Mailsmith in place. And that's why this code is still working. And that kind of highlights the danger of the redirects, because this code has been like this for a while, and it just kept working even after that Superwolf user disappeared. So basically, this is a hijackable. This right here is vulnerable to repo jacking, and you can inject code in there. So that's the 18,000 impacted projects, right? Those are the ones that are directly vulnerable. But that's not the whole story, because Algorithm Search Helper is one package that's depended upon by other packages, right? So you have to look at everything. So what depends on this package? So then you build out that graph, and you take a look. Okay, view instance search. What depends on that? And you just keep going down. View CLI.u. Keep going until eventually you reach a really interesting project. In this case, it's the Vue.js command line tool, Vue CLI, and it depends upon through a series of dependencies, it depends upon the Algorithm Search Helper. And for those familiar with the Vue CLI, that's essentially the command line tool for doing Vue operations, which is one of the largest web frameworks in the world. So essentially, because of repo jacking, what you have is you've got this Superwolf user change their name or delete their account, and because of that, and through the supply chain you know, in the dependency chain, Vue is now vulnerable to code injection. So, you know, a malicious attacker would re-register that superwolf name, that Mailsmith in place repository, would kind of create code that'll go up through the dependencies and eventually get into the main CLI. And from there, you know, the impact they could have is tremendous. So that really highlights the importance of doing this this dependency analysis as well, because, you know, looking at a single directly vulnerable repository doesn't get you the whole image of the impact. Okay, so we got our 18,000 projects which are impacted. Do the analysis, right? So now we got to see what's actually vulnerable through that graph. So do for a depth 1, we're up to 14,000 more, 32,000, 38,000. As we keep going down through the depths. And then eventually, after like a depth of 5, we have 70,000 impacted projects. Now, we actually have to stop after 70,000 because part of those were actually huge web frameworks and libraries that are used by basically everyone, like that concat map example, for example. And as we tried to do the next level, we physically couldn't process it. It just took too long to process all the ones which should depend on them because they're so big. And so that's the point where I said, okay, this is, you know, this is enough. This is clearly extremely widespread, and that's all. And so that's where we stopped at. So the key findings from this research and this kind of mass analysis was that there's about 70,000 affected open source projects, only up to depth 5, right? There could be so many more past those depth levels. And if you add up all the star count, like the GitHub star count of all those projects combined, they have over 1.5 million stars, which is a huge amount, right? Like the biggest GitHub repository has like 300,000 stars. So this is a number of times, you know, larger than any individual project. And it affected basically everything, right? Because it's not language dependent. It goes, you know, any language can pull from GitHub URLs. So it affected, you know, Java, Python, Go. It went all over the place. And then it also affected basically every major organization that has open source. So like Microsoft, we found some Google, some Facebook, GitHub themselves, so we're vulnerable. So it impacts basically everyone. And this one is a little hard to determine because, you know, different package managers use different ways of calculating downloads, and they don't always make it available. But there's at least 2 million, at least the bare minimum would be 2 million daily downloads of these impacted packages and projects. You know, so that impact alone is tremendous. So we got all this data now. I thought it'd be interesting to load it up into a graph and kind of get a visualization as well. So here's a visualization we built. Essentially, this is a project, this node, with 1,000 downloads a month to kind of give you the size. And these are all the directly vulnerable projects. So everything here are projects, and each project gets their own little node sized up based on how many downloads they have. And you can kind of see already based on that $1,000 a month, just which some really big projects are directly affected by this. And then we walk down the dependency chain. This is a second, at depth of 2, what's affected. At depth of 3, you see some big dependencies starting to kind of crop up, and you kind of see how they're all getting pulled together by the different links. And there's some really interesting kind of analysis to be done here just by looking at this. Like for example, this node over here, which seems to really touch onto everything. The node in kind of the bottom right side there. And there's also some interesting bundling if you look all the way on the left over here. You can kind of see all the nodes sticking together, and that's because they're interconnected, you know. That's step 4. And then once we hit step 5, this is where we had to stop, right? If you just look at this, it makes sense because virtually every single one of these nodes are huge libraries and frameworks used by everyone. You know, if this is Vue, you can just kind of imagine what these big frameworks are over here. So we had to stop because obviously this graph would have completely exploded on the depth level 6. So I thought this is a really interesting way to kind of visualize just the impact that this has. And you can't see that initial 1,000 download a month node anymore. So we've talked about the actual vulnerability. Now we have to talk about some remediations, right? So the biggest remediation, if there's anything you're gonna get out of this talk, is don't link directly to GitHub repositories, right? That's the most straightforward way you remediate this, because GitHub URLs are not meant to be like immutable locations, essentially. That's what package manager is for. So always use a package manager, npm, PyPy, Composer, whatever you use for your language. That'll kind of ensure their job is to do that, to make sure that you're downloading exactly the ones you want to. And GitHub URLs don't offer that safety. If you're currently the maintainer of a project, open source or private or whatever, I highly recommend you go right now after this talk, look through your source code, and even just a search for github.com or whatever, and try to see if you're linking to any GitHub URLs. And if you are, you might be vulnerable already to repo jacking if those usernames can be reused. So just don't do it, and that's the easiest way, right? A second way that you could protect yourself is through version pinning. So pin your dependencies to a specific version. So the astute of you will have noticed in that example of Algolia search, there was a little hashtag and a git commit hash at the end. And that's version pinning, where you basically say to your package manager, only download this specific commit. So by only downloading that specific commit, it will, it'll ensure that no other commit is downloaded. So I did kind of take a look at this as part of this research, and for basically all of the major package managers I looked at, we were able to bypass that version pinning. So version pinning is definitely not a one fix all there. So it can be bypassed, and a lot of them through a bunch of different kind of nifty ways. I don't want to get too much detail because I'm still kind of in the process of remediating these with some of the package managers, but definitely keep an eye out for an upcoming blog post that goes into more detail on this. And the other thing is, don't pin to a tag or a branch. Version pinning can pin to a tag or a branch of a repository. Don't do it because tags and branches are not immutable. Anyone can change those or delete them. And then the last remediation you can take on are lock files. So lock files is basically a file that ensures that only a specific version of a dependency is downloaded, and those might have an integrity check to make sure that there's nothing funky going on and it's exactly the version you wanted. The thing is, log files aren't always used from security point of view. So some people use log files to ensure that other developers get the same version as them. So there's no bugs or anything or no untested code. So for example, this is the npm log file. If the package comes from npm, it'll include an integrity check, which is good, right? Because I'll make sure that nothing can happen down the line. But if the package comes from GitHub, like in this case, the express case at the bottom, you'll notice that there is no integrity check. And all it relies on is that commit hash. And as we talked with version pinning, that can be bypassed. So be aware of lock files. They can definitely help, but they're not the one fix all either. The biggest is don't link directly to GitHub repositories. So basically the TLDR of this talk is GitHub repositories can be hijacked through repo jacking, and you should never link directly to them, or else you could have a code injection vulnerability. So just don't do it. I've written an article about repo jacking at the Security Innovation blog called Repo Jacking, Exploring the Dependency Supply Chain, that I would encourage you to read if you're interested in this. There's some more analysis there and some different things I couldn't get to talk about here. And I will also be posting another kind of upcoming in the coming weeks article about the version pinning bypass and some other kind of interesting findings that we had and kind of how we went about trying to help remediate this issue. You can contact me at any of the standard places, and thank you very much for listening to my talk.
That was awesome. That was really cool.
Very good talk. You did have a couple of questions come in through the Discord. Somebody said, wouldn't it be like really easy to write a script that goes through all the possible dependencies that could be used to target a given library? Which you touched on in slide 8, I believe.
Yeah.
Is there more you wanted to comment there?
Yeah, I mean, it would definitely be easy for someone to go through that and do that analysis themselves and find all the everything that's vulnerable. And that's kind of the danger here, is that it's really easy to find and it's really easy to exploit, which is kind of a double whammy in terms of impact.
Yeah, no, that's awesome. Did we have other questions in here before?
So I don't see any questions in the chat for GoToWebinar or in the questions panel.
So I had actually put in the Discord, this is clearly bonkers pants, and G Dynamics put in there the same thought I had. Simple but deadly is the best things are, or I guess worse.
Absolutely.
It depends on your perspective. Yeah, no, that was. How did you do the scanning? Was it a script you put together? How did you go through and find those links?
That's actually a great question. So that data set I talked about, the GitHub activity data, is actually loaded into Google BigQuery, which is basically Google's kind of cloud offering for querying large amounts of data. Because it's a 3 terabyte data set. So downloading that and sifting through would be hard. But Google could do it in just a couple of seconds using their engines, and they allow for regex. So basically, I made a big, super long, complex regex, extracted all the GitHub links, and then from there, I could just kind of go to the individual files and do my analysis.
Yeah, that's cool. Yeah, because that was my first kind of thought there. Not necessarily the size, but that you have that data that you were able to go through and do that. So that's really, really, really awesome. You said you're working with some repos right now, or you're working with some folks right now. Without saying who they are, obviously, because you're trying to work with them. But are you seeing when you do reach out to people that they're generally, ooh, hold on, yeah, let me go fix that, or oh, let me go change this? What kind of reaction are you getting when you talk to people?
Yeah, so I've actually had some really positive reactions. I've published the blog post, so a lot of people read through it and they're like, okay, yeah, that makes sense. I get what's going on here. And the fact that it's a pretty simple fix, right? Just point somewhere else, get a package manager or whatever, makes it a lot easier for people to be like, all right, yeah, you got me, and then they fix it right there. But yeah, I've had some really positive kind of feedback, and a lot of people, especially with the repositories we're contacting, which are really huge and large repositories, really understand the importance of security. So yeah, they jump on it right away.
Yeah, no, that's great. Yeah, very, very, very good. And this talk as well will be recorded. Well, it is recorded and it'll be up on the YouTube there, YouTube for Grim. And I'm going to point some people to this because excellent work. Tabitha, Delaney, any other questions? We have any other questions coming in, or do you have other questions?
I didn't see any other questions come through. I thought it was just to reiterate, like, just what a dead simple thing to be able to fix and remediate, once you know about it.
Yeah, absolutely. Knowing is half the battle, right?
The other half is red lasers and blue lasers.
I had no specific questions myself, but I did want to comment that in speaking, your pacing was remarkable. You're a very excellent public speaker.
Well, thank you.
So a pleasure to listen to.
Very good. And this was your first talk, huh? So
yeah.
We'll many more.
Yeah, I will be presenting this talk to a couple other places coming up, and also be including some kind of further analysis as I continue to look into this and kind of go from there.
Very good. All right, well, feel free to hang out here a little bit. We got about 15 minutes till the next talk, but if you got other places to be, are you going to be hanging out in the Discord or be in the virtual happy hours?
Yeah, I'll definitely be available in Discord for any questions or any comments. So yeah, okay. So I'll be there, and feel free to reach out to me.